Okay, we are going to finish this, and this should work. Okay, so I think this is where the last video cut off. So what we're doing here, remember this f of x, we can always replace f of x is just kind of the fancy way for saying y. So here we're just saying y equals 1. So I just need to go to my graph and I say, here's y is 1. So what on the function, what does that mean on the function? Usually if I have a y value and I'm looking at a graph, that means I'm going to look for an x value, right? Because points are x, y. So I look at my y equals 1 and I see I've got a point right here at x equals 1. And then I've got a point right here at x equals 4, negative 4. So that's my answer. Then for down here, this is asking what f of 3 is. So I think of it like this. If I have f of x, which is the graph above, and they want me to find f of 3. You can see here that I'm replacing this x value with 3, which is kind of like saying x equals 3. So that's what this question is saying. They're saying at x equals 3, what's my y? So I just look up here, and I'm saying f is 3, y negative 3. So I've got a point right there. And you could look above, but we've got nothing above. So my answer is just that. Y equals negative 3. Okay, now they want to know the range. So when they're asking about the range, it's talking about our y values. And the domain is referring to our x values. So we don't need to worry about the domain for this question, but for the future, we'll see a question later on that will deal with that. So the range, we're just looking at our y values and seeing what y values we can have with this graph. So I'm going to start from the bottom. And if you see how this has an arrow, which means it's just going on and on, same with this one. So this graph is going to go all the way to negative infinity. It's just going to keep going to negative y values, okay? So my range, it starts at negative infinity, and then I come all the way up, and 3 is the highest I can go. You see at 4, I don't have any y values. Same with 5, right? At 3, I've got this 1 point. At 2, I've got these ones. So I have values all the way up till 3. So my range is negative infinity and 3. And it's going to be a bracket because we include 3. That 3 is included. I have a point right there. Okay. Let's come down to this one, number 16. So it says find an equation of a line passing through negative 5, negative 1, and 3, 1. So we're going to want it in this form, y equals mx plus b, like we talked about before. So our first thing is going to be to find our slope. So if you remember, our slope is y2 minus y1 over x2 minus x1. So I'm going to label these points x1, y1, x2, y2. Now I could switch this. I could decide that this is my x2 and y2. I would get the same answer. What's important here is that I can't have this be an x1 and this be a y2. These both have to be 1, these both have to be 2, or these both have to be 2 and these both have to be 1. That's the biggest thing. So I'm just going to label it so I don't forget. Now I'm just plugging it in. So my y2 is 1 minus y1 is negative 1. x2 is 3. x1 is negative 5. And so these negatives don't confuse you. I would just put it in your calculator, 1 minus negative 1. 3 minus negative 5. Okay? I'm going to do my trick because it just helps me see it. but that's what I would recommend, just putting it in your calculator. So we have 2/8, which equals 1/4. So this is my slope, this is my m value. So I have my m value, now I need a b. I gotta figure out what my y-intercept is. So to find b, what I'm gonna do is I'm gonna plug in an x and a y value, because then I'll have y, m, and x, and I can solve for b. So I'm going to choose one of these 2 points. It doesn't matter which one, but again, if I choose -5 as my x, I've got to choose this y. I can't flip-flop them. So I'm going to choose 3, 1. Again, it doesn't matter, you'll get the same result. So now I'm just plugging it in. So I have 1 equals 1/4 times by 3 plus b. And this equals 1 equals 3/4 plus b. And now we're running out of room, but I got to subtract 3/4, subtract 3/4. So I have b equals 1/4. Let me make sure. Yes. So b equals 1/4. So now I've got my b value and I've got my m value, both equal 1/4. So now I just need to write it in slope-intercept form, which is this right here. So this would be another one good thing to write down probably on your note card. The slope-intercept form is going to be this. And when you're finding slope-intercept form, this m and this b are going to be a number. The x just stays as an x and the y just stays as y. So my answer here is y equals 1/4 x plus 1/4. And that's my answer. Okay, so this number 17 is very similar, except I'm given an equation and they want to know the equation of a line that passes through a point that's perpendicular to this equation that they gave us. So when it's perpendicular, and this might be good to write down too, perpendicular, the slope is going to be opposite, and I'll explain that more. And if it's asking for a parallel slope, the slope stays the same. So first thing, for perpendicular, I need the slope to be opposite of this. So first I need to find the slope. So I'm going to put it in the y equals mx plus b form. So I have 5x plus 2y equals 8. And I want this to get y equals. So first I'm going to subtract the 5x and subtract 5x. So I have 2y equals, and I'm going to put the 5x first because I prefer it that way. So I'm just going to make sure that negative stays with the 5x and then the 8's positive. Okay, now I just need to divide by 2. Divide by 2, divide by 2. So I have y equals -5/2 x plus 8 divided by 2 is just 4. Okay, so now from this, I can see that my slope is -5/2. That wasn't a great color, sorry. So I have my slope. So now to find this new slope of this new equation of the line, it's going to be the opposite. So what that means is that the slope right now is -5/2. So I need to flip them. So I need to now do 2/5 and change the sign. So instead of a negative, it's now going to be positive. So this is my new slope. If it was parallel, if they were asking us to find a parallel line, this would be my slope, -5/2. Okay. So now I've got the slope. I'm just doing the same thing I did before, where I have this point. So I have an x and a y value, and I need to find what b is. So I'm going to say -3, and that comes from this y right here, equals 2/5 times by 5 plus b. And I'm getting this because I want to get, my answer is going to be in this form, y equals mx plus b. So now do this in your calculator, but what I end up with is negative thirds equals 2/5 times 5 is just 2 plus b. Now I'm going to subtract 2. So I have b equals negative 5. So now that I've done all that, I can just put it in my equation. So I have y equals m, which is 2/5, x plus 5, or plus b, which is negative 5, so minus 5. And that's my answer. Okay, we're going to do this one next, and then we'll get to the other ones. So if this wants to find the domain, and remember, domain means it's dealing with our x values, and the range, which is our y values. So this one's not too bad. My x value for my domain, I'm literally just writing down my x values. They probably want it in numerical order, but we don't care. Let me check one thing really quick. Okay. So I've written it like this, but here's the thing. I already have this negative 5. I don't need to write because I already have this negative 5. And this 7, I don't need to write because I already have 7. I don't need to repeat values. I already have the negative 5. There's no point in me writing it twice. Okay, and then for our range, it's the same thing. 11, negative 4, 3, 5, and this negative 4 I'm not going to write down because I already have a negative 4. Okay? Pretty simple. Just writing y values, x values down. Okay, they want to know if it's a function. So if something's a function, my x values, well, no x values are repeated. So if I don't have any repeated x values, then it is a function. But because I have a negative 5 and a negative 5 and oops, that's a y value, and a 7 and a 7. So 2 negative 5s, 2 negatives, not negative, oof, 2 7s. This means it is not a function. This is also, if they show you a graph, you could do the pencil test. So basically, if I run a pencil over it vertically like this, up and down, let me draw it. If I come across like this, does my pencil ever touch the line in 2 spots? In this case it doesn't, so I'm fine. But in a case like this, do you see how right here, it touches right there and right there? And same with here, and basically everywhere. So this one is not a function. Where this one would be. So that might be another good thing to write down on your piece of paper. Okay. Those are kind of the ones I'm thinking you'll remember. So we're gonna now start with the story problems and stuff that not necessarily trickier, but you may not remember. All right, so we really struggled with these type of problems back when we did them. That was my bad. They're not too hard, at all. I was just thrown off with them. So what it's saying is how many milliliters of a 51% acidic solution. So I'm going to underline that in pink. So we have this pink solution, and we want it to be mixed with this purple solution. To get this solution, this green. Okay? So I'm going to write two equations down. So my first equation is I'm going to have x, my pink solution, plus my purple solution, and I'm just going to label them x and y, and that's going to equal the 150. So basically, I'm trying to figure out how much of each solution I need to get 150. Okay, so I'm just saying x, this solution plus this solution is going to give me 150 milliliters. Then I'm going to write a second equation down, and it's going to be the same thing. But this time, the second equation, I'm going to multiply by the percentage that's attached with them. So this pink one has a 51 percentage. So in front of the x, I'm just going to times it by 0.51. Right, 51% equals 0.51. So then for my y, for this purple solution, it's a 66%. So I'm just going to times that by 0.66. And then this 150 has a 55%. So I'm going to times that by 0.55. So now all of this is going to equal, I'm going to have 0.51x plus 0.66y is equal to 82.5. And then I have x plus y equals 150. So now I've got a system of equations, which we can solve. Yeah. Molly, you're just interrupting up. So now you're going to have a system of equations. We're going to come back and solve this. I'm going to do a simpler system of equations first for you so you can remember how to do it. But this is the general setup, which shouldn't be too bad, and I totally think you're capable of doing it. So we're going to come down. Sorry, we're skipping around a lot. Okay, to right here, to number 18. So this is solving a system of equation. There are two ways to solve a system of equation. Well, there's three ways. So the first way is substitution. Second way is elimination. And third way is using a matrix. And we're going to go through all of these. So substitution, well, elimination, you're usually going to use if you have three variables. Substitution you'll use if you can get an x equals something, a y equals something. So whether that's given to you or it's really easy to solve for x or y, that's when you're going to do it. Matrix you'll only do when they ask you to do it. So for this one, because remember substitution I use if I've got like an x equals everything or y equals everything. So if I scroll up here, you see the second one is y equals x minus 1. So I'm going to use it. I should say this first though. You can use any one of these three and you'll get the same answers. Sometimes it's just like this problem that we're about to do is set up nicely to do substitution. You don't need to though. You could do any of these three and you get the same answer. Okay. I'm going to use substitution though because it has this y equals whatever, which is just set up really nice. So what substitution is we're substituting in something. So I have this y equals x minus 1. So since I know what y equals, I'm going to plug it into that first equation. So I have the first equation is 5x minus 3y. And instead of y, I'm going to replace it with this x minus 1. Because that's what y equals. That second equation tells me what y equals. Equals 7. Okay, so I've got that. So now I'm just going to multiply it out. So I have 5x negative 3 times x is negative 3x. Negative 3, remember this negative goes with the 3. That's where people get stumped. Negative 3 times negative 1 is positive 3, which equals 7. I can combine like terms. So 5 minus 3x, 5x minus 3x is 2x, plus 3 equals 7. Now I'm going to subtract the 3, subtract the 3. So I have 2x equals 4. Now I'm going to divide by 2, divide by 2. So I have x equals 2. So awesome, I found my x value. Now I need to find my y value. When you're solving for a system of equations, it always wants you to find an answer for the variables. In this case, we're only given 2 variables, x and y. So I've got my x. So now to find my y, I just need to plug x in for one of these 2 equations. It doesn't matter which one. I'm going to do this one because it's set up nice where I'm trying to find y and I have y equals something. So y equals x minus 1. Instead of x, I'm going to put 2. So 2 minus 1, which is just 1. So these are my answers. So that's not too bad. Okay, now we're going to do one. And if you remember here, I said I think it's best to do elimination when you have 3 variables. So you have like x, y, and z, which we're going to see in this next one. So remember, substitution, I'm subbing in a variable. Or elimination, what I want to do is I want to eliminate a variable. So this one, I have x, y, and z. You can do substitution for this one. I just think elimination is easier when you have 3 variables. So I'm trying to eliminate a variable. And how I can eliminate a variable is I can add or subtract equations together to try and get rid of one. I can also multiply equations by a number. So if I need to, like this third equation, well, I'm going to number these. We have 1, 2, and 3. If I needed to, I could times equation 3 like all by 4 and then add it to an equation if that helps me get rid of something. In this specific case, I see that all my z values are all 1, which means if I add or subtract them to each other, they're going to cancel out, especially if they have opposite signs. So that's just something you got to kind of notice. You could do it with the x's too. The z's, it's just nice because they're all the same value. So what I'm going to do is I'm going to say, I'm going to take equation 1 and I'm going to add it to equation 2. So I'm going to write equation 1, which is 2x plus y minus z. I'm going to add it to x plus 3y plus z. So 2x plus x is 3x. Oops, I need to put equals 5 and equals 14. Y plus 3y is 4y. And then this is what I want. I've got negative 1 plus 1, which gives me 0. So my z's are gone, which is the whole point. I'm trying to eliminate a variable. So that's great. And then 5 plus 14 is 19. Okay, awesome. So now I want to do it again and eliminate z so I have 2 equations. So I'm now going to take equation 2 and add it to 3. The reason I'm choosing those, you could choose any ones, but I just see that the z values, like I said before, are the same. They're all 1. And then I've got a negative and a positive. So if I add those together, they'll cancel out. And if I add this negative and this positive together, they'll cancel out. So equation 2 is x plus 3y plus z equals 14. And equation 3 is x plus y minus z equals 4. X plus x is 2x. 3y plus y is 4y. And then my z's cancel out, which is what I want. 14 plus 4 is 18. Okay, so now I have two equations. I got 3x plus 14y equals 19, and I've got 2x plus 4y equals 18. This isn't supposed to be 14, this is supposed to be 4. Okay, so now I have two equations. So I can either use substitution or elimination. I'm going to use elimination again just because I don't, because I want to, and because I'm showing you it, and I think it's easier. The reason why I think it's easier is you notice how our y values both have a 4, so it makes it pretty easy. So this time, instead of adding these two together, I'm gonna, this is, I'll say equation 4 and equation 5. So instead of adding them together, I'm gonna subtract because these y values are both positive. So if I add them together, it will be 8y, but if I subtract them, it will be 0, which will get rid of my y's. So I'm gonna say 4 minus 5. So I've got 3x plus 4y equals 19. And I'm going to subtract 2x plus 4y equals 18. So I have 3x minus 2x, which is just x. 4y minus 4y is 0. 19 minus 18 is 1. So I've got what my x value is. Now I need to find my y and my z. So to find my y, I'm just going to plug it into one of these. It doesn't matter which one, to find my y value. I'm just going to take the first one. So I have 3, and my x is 1, plus 4y equals 19. So I'm going to subtract the 3, subtract the 3. So I've got 4y equals 16. And then if I divide by 4, I have y equals 4. So I have my x and my y. Now I need to find my z. So I'm going to choose one of these equations and find my z. I'm going to use this bottom one, the third equation, just because it looks easier. You can do whatever though. So my x is 1 plus my y, which is 4, minus z equals 4. So I have 5 minus z equals 4. Then I'm going to subtract the 5, subtract the 5. So I have negative z equals negative 1. And now I need to get rid of that negative because right now I have negative z and I need positive z. So I'm going to divide by negative 1, divide by negative 1. So I get z equals 1. So those are my answers. A lot of work, but it really isn't too bad. Okay, the third option for solving a system equation is to use a matrix. So this is the thing that I didn't do a good job of explaining. So it was a little difficult. He has given practice exams on Canvas. He listed 4 and only one of the 4 finals asked you to do a matrix. So I think the likelihood of you needing to solve a matrix is very small, but I'm going to show you, like at the very least, you'll be able to set it up and then that's at least some points. So I think it's beneficial for you to see, so maybe you can like try and do something, but it's just one of those things where like it is a little difficult and it may not even be on the exam, so you may not get full points, but at least like if you set it up, you can get partial credit. So to set it up, and I think you're going to remember this, I basically get rid of just the variables. And I'm just looking at those coefficients in front. Oops. So it's kind of like this column is my x values, these are my y's, and this is what it equals to. So I said x, there's 2, 2, 3, 3, and it's equal to 13. For this x, there's like an imaginary 1 there, because I just have 1x. This is -4, and this is 1. So I think even if you just set this up, that's awesome. Like, that's a big thing to it. Now, I'm going to go over this, but don't stress about it. Our goal when doing matrices is to get it in this form. 1, 0, 0, 1, and then this will be some number. But we want to get a 1 right here, and a 1 right here, and zeros right there. And this column, the stuff that it equals to, will just be random numbers. So the way we do this is, these are our rows. The rows are here. So what we're able to do is we're able to switch rows if we want to. We are able to add and subtract rows to get us what we want. So it's kind of like when we were doing eliminations. And if you remember how I said I can times like one row all by a number if it helps me eliminate stuff. So it's the same thing. I can add and subtract rows, and I can also times a row and then subtract it or add it to a different row. Okay. So the first thing I'm doing when I'm solving for a matrix is I want to get a 1 right here. So where this 2 is, I want a 1. Now I notice that if I flip these 2 rows, I'm going to have a 1 in that spot. So first off, I'm going to label this as row 1 and row 2. So right here, I'm just switching row 1 with row 2. So now this row 2 is going to go on top. So I have -1, not -1, 1, -4, 1. And on bottom, I have 2, 3, 13. Okay. Awesome. So now this is my new row 1. This is my new row 2. Next thing I want to do is I want to get this to be 0, right where this 2 is. So I notice that if I times this one right here by -2, then I'll have -2 plus 2, which will give me 0, which is what I want. So this is where it gets tricky, but if you just pause and kind of like step by step with what I'm doing, I think you'll kind of see the basic idea. So what I'm doing is I'm timesing -2 times row 1, and I'm adding that to row 2. So I times row 1 by -2, so I have -2 minus, well, that turns into a +8 minus 2. And my row 2 is still 2, 3, and 13. Now, so this is my new row 1, this is my new row 2. Now, if I add those together, so I add row 1 plus row 2, I'm going to get my new row 2. This will give me my new row 2. So I have -2 plus 2, which is 0. Then I have 8 plus 3, which is 11. And then I have -2 plus 13, which is 11. And now I have a 0 here, which is what I want. Now I'm going to keep this original row 1 because I want the 1 here. Having this -2 here doesn't help, so I'm going to switch it back to what I originally had. 1, -4, and 1. Now my next step is to get a 1 right here where the 11 is. So I'm going to divide all of row 2 by 11 because that will get me a 1. So I've got row 1, row 2, and if I divide row 2 by 11, so my 1 stays the same. I'm not messing with my row 1 right now. But now on bottom, I have 0 divided by 11, which is just 0. 11 divided by 11, which is 1. And 11 divided by 11, which is 1. Okay, Awesome. So I have this 1, 0, 1. Now I want to get this -4, a 0, and then I'm done. So I notice if I made this one right here a 4 and I added them together, I'd get a 0. So to get this to be a 4, I need to times the whole row by 4. So I'm going to times 4 by row 2. So my row 1's going to stay the same. 0 times 4 is 0. 1 times 4 is 4. 1 times 4 is 4. So now what I want to do is I want to add row 1 plus row 2 to get a new row 1. So 0, 0 plus 1 is 1. 4 plus -4 is 0. 4 plus 1 is 5. And then my row 2, remember I don't want a 4 here, so I'm going to go back to my original one. So I'm going to have 0, 1, and 1, which is what I want. I wanted a 0 right here, 2 zeros, 2 ones, and then these are just numbers. So that's what I want. So if I remember, this is my x values, these are my y's, this is what I equal. So if I rewrite this top row, I have 1x plus 0y equals 5. And on bottom, I have 0x plus 1y equals 1. So I have two solutions. I have what my x equals and I have what my y equals. So that's my answer. So that's the general idea of that. Again, if you just set it up and you even kind of like told him what like our goal was, that's better than nothing. Okay, so we're going to go all the way back up to this, solving a system of equations. I'm going to choose to use substitution for this one. So what I'm going to do is I'm just going to rewrite this to be x equals 15 minus y. And if I just subtract this y over, that's what I get. So now I have x equals something, so I'm going to plug it into this equation. So I have 0.51 times by x, which is 15 minus y, plus 0.66y equals 82.5. Okay, so now I multiply this out. So 0.51 times by 15 is 7.65 minus 0.51y plus 0.66y equals 82.5. I'm going to add like terms, so my y values, and I'm going to subtract the 7.65 over. I'm going to do 2 steps. So negative 0.51 plus 0.66 is 0.15y, and 82.5 subtract 7.65 equals 74.85. Again, if I'm going too fast, just pause it. And I'm dividing by 0.5, divide by 0.5, 0.15. Ooh, that can't be right. I got y equals 499. Oh, maybe that is right. No, it's not. Okay, sorry, Amy. I'm not gonna sit here and try to find my mistake. I'm sure some mathematical error. You might have seen it when I was doing it. But the point is I'm gonna have some y value, and once I find my y, sorry, someone's calling me. Once I find my y, I can plug this back into like this equation to find my x. Okay, because they want to know how many milliliters of my x and how many of my y. So I'm trying to solve for x and y. So that's what you would do. I don't know where I went wrong. This is just the big answer. But I mean, it could be wrong, but right, but I just looked and it's wrong. So that's the general idea. We can totally go over that one too. Okay. So number 9, I forgot about this one. So they want to know what the domain of the function is. So the domain is our x values. So when it's asking for the domain, usually it's all numbers. Usually I can have any x, like negative infinity to infinity. But in this case where we have a fraction, I cannot have a 0 in my denominator. I can't have this, like, I can't have 7 divided by 0 because that doesn't exist. So, so if I have a fraction a, b cannot equal 0. And you might want to write that down in your notes. So what I'm doing here is I'm just going to say, take my bottom, which is x minus 7, and set it equal to 0. Because I want to see where that equals to 0, because then I know I can't have that in my denominator. So now I'm just solving this. So I add 7, so I have x equals 7. So this, my x can't be this. But my x values are going to be able to have everything else. So my domain is going to go, I can go from negative infinity all the way to 7, parentheses though, because I can't include 7. I can get to like 6.999, but not to 7. And then the union, and then it's going to start back up at 7 again, but again, it's a parenthesis because it doesn't include 7, and it's going to go all the way to infinity. So this is kind of, it wants us to write interval notations, which is what we're doing. But we're saying, basically this is saying our domain can be any number except for 7. The other one you might see is if they give you a function with the square root. So if they give you a function with the square root, you just can't have a has to be greater or equal to 0. You can't have a negative under there. So that's how you would solve that one. Okay, this one. Okay, so this one isn't bad. So story problems I recommend. Like fully reading it, because this is totally a problem that you could do. So just don't let it freak you out. So it says a truck rental company rents a moving truck one day by charging $35 plus 18 cents per mile. And they want us to write an equation. So if the equation seems daunting, just think about it. If I said, okay, so you rent this truck and you go like, well, okay, let's say for my example, if this truck company charges $35 and then $1 for every mile you go. So if I say you rent this truck and you go for 5 miles, how much did it cost you? So in your head, you would say 1 times 5, right? $1 for every 5 miles. So I had to pay $5 for the amount of miles I did, and then plus $35. So I would have to pay them $40. So what you did is your total cost is going to be the amount they're charging you, which in this case is 0.8, times by the number of miles you went, which is, I'm going to say is X. They tell me that. And then I have to add 35 to that. And that's all they're asking for. And so just think of it as like a simple, like realistic example that you might do. So then this is asking, what is the cost of renting a truck if the truck is driven 90 miles? So I'm just saying, well, 0.18, so 18 cents for 90 miles. I mean, this is just our X value, so you can just plug it in for X. And then I have to add that $35 because they're charging everyone $35. So now I just put this in my calculator. 0.18 times by 90, 16.2, and then I just add 35. So I've got 51.2. So that's going to be the cost of it. Not too bad. So just read them because you got it. Okay, last problem. Okay, these ones I really struggled with too, but they're not bad. So the important thing to know about anything with either flying or them like taking a boat is that our distance equals our rate times the time. So I'm going to make a chart that gives us distance. I'm going to call D rate and time. Okay, so it says Rhonda flies a plane a distance of 912 miles. So my distance is 912. And she's flying into a headwind. So I think of it as she's flying this way, she's flying into the wind. So the wind's coming this way. And the trip takes about 8 hours. Okay, so her rate is going to be how much she flies. So let's do R for her flight plus, well, let's do P for plane. So it's going to be P and then subtract. So it's going to be, because she's going this way. So this is P and this is the wind. Subtract the wind because she's going against it. Okay, they're going opposite directions. So we're subtracting it, and that's the rate. So it's the rate is how fast she's flying, and then we got to subtract this W. Okay, and then it says the return flight takes less time because the wind is still blowing in the same direction. So now she's going with the wind, right? So now she's going plane and the wind are both going this way. So her rate is going to be the plane plus the wind. The distance is going to be the same. And it says it only takes her 6 hours this time. So now we got our chart. So now I'm going to just use this equation right here. So I'm going to have two equations. I'm going to have this equation and this equation, 1 and 2. So for 1, I have the distance, which is 912, equals the rate, which is P minus W times the time, which is 8. And the second equation is going to be 912 equals P plus W times by 6. So now I'm going to multiply these out. So I'm going to have 912 equals 8P minus 8W, and 912 equals 6P plus 6W. Now we have a system of equations, and I need to solve it. Let's solve it using substitution again. So this one I'm going to rewrite. Well, let's see, this 912. It doesn't matter which one you choose. I'm going to choose this one though. So I'm going to subtract the 6P over. So I'm going to have 912 minus 6P equals 6W. And then I'm going to divide by 6. Divide by 6, divide by 6. So I have 912 divided by 6 is 152 minus P equals W. So now I have that my W equals something, so I'm going to plug it into this first one and solve. So I've got 912 equals 8P minus 8 times W, which is 152 minus B. So this is just like the acidic problem with where we're mixing two solutions. So I have 912 equals 8P, 8 times 152 negative 1216, and positive 8p. So now I'm going to combine like terms, and I'm also going to add this 1216 over. So I have 2128 equals 16p. Divide by 16, divide by 16, and I have p equals 133. And they want to know what the speed of the plane is. And speed is the same thing as our rate. So this is my answer. If they want to know the speed of the wind, and they want to know the speed of the wind, I plug P in to one of these equations to find my wind. So I have 912 equals 6 times 133 plus 6W. 6 times 133. Got 912 equals 798 plus 6W minus 798 minus 798. 114 plus 6W. Divide by 6, divide by 6. So the wind speed is 19. Which makes sense, right? The plane's probably going a lot faster than the wind. Okay, I think we did them all. I will email you along with this, like these handwritten notes. But again, I think it's going to be better. Hopefully you wrote them down. I think that'll be better than just looking at mine. For this first one where we didn't finish, just for the sake of time, I'm not going to, because once you set it up, the principle is just the same as what we did, just barely. The answer key for this is on Canvas. I stole this from Canvas. It's under exam 1, like preparation. So that he has a practice exam and then the key to it. So you can always look there and see. But yes, hopefully you understand it all, and just let me know if you have questions.